Hello, ladies and gentlemen. Mr. Miller here again for you. This week's, or actually new chapter, 2.1. So we're going to be looking at inequalities in this chapter. This first section here is writing and graphing inequalities. So you'll be able to write linear inequalities from a graph. So write linear inequalities from a graph. Oops, F-R-O-M, a graph. Second, you'll be able to sketch the graphs of linear inequalities. So sketch the graphs of linear inequalities. And again, inequalities, I-N, well, it's spelled at the top of your sheet too, so you can cheat from right there as well. So spelling that out. So write linear inequalities from a graph and sketch the graph of linear inequalities. So we got a couple warm-ups here, just making sure that our algebra skills here are staying up with us. So in this first one here, it says, is minus 9 a solution of a plus 7, which will equal a minus 2? So if we want to know if that is a solution, we're going to substitute that in. So we're going to take that minus 9, substitute it into the a. So we'll rewrite our equation. Minus 9 plus 7, does that equal 2? Clean it up on the left side. So we get a, almost forgot my minus sign. Get a minus 2 on the left, and it is a minus 2 on the right, because I almost forgot my minus sign up here from the original one. That's always something you got to watch out for, ladies and gentlemen. So you can see I almost forgot it there. So considering they're both equal, exactly the same on both sides, minus 9 is a solution, so yes, it is. Second one, we have a one-step solve the equation here. So single step, I want to get h all by itself, figure out what that is going to be. So here we have a positive 12, so again, to undo a positive 12, to move it over to the right side, we do the opposite, so minus 12, and then we get, cleaning it up here, h is still on the left side, and then a minus 8 and a minus 12 is a minus 20. So you just want to watch that. I like to check my work on these also, ladies and gentlemen, in case you do make a mistake on these. A little harder to check the first one, but this one's a lot easier. Take your answer and plug it back in. So make sure that that minus 20 plus the 12 does come out to minus 8. All right, so going back and checking our work, and yes, we do get minus 8 equals minus 8. So I know h equals minus 20 is 100% correct. Please continue to do that if you've been doing it. If you haven't been checking your work, I really highly suggest it because it does help you stop from making those dumb little mistakes. Like some people might think, of adding here instead. So it's very easy to get like a 4 answer out of this. So positive 4, which again, positive 4 unfortunately would not work. So please just watch that. Third one, this one actually is getting into writing inequalities here, but making us think a little bit outside of them before we get into them. So here it says, write an inequality that describes the number of Blu-rays you can buy for $12 each if you have no more than $60 to spend. You can buy 6 Blu-rays. So on this or can you buy 6 Blu-rays, it's asking. So on this particular one here, it is an inequality. I'm gonna set it up as an inequality, but you can kind of think about it as, all right, multiples of 12. So I have $12 for each Blu-ray. So how many times does 12 go into 60? So you can start to think, okay, if I spend $12 on one DVD or Blu-ray, and I spend $2 or buy two of them, that's $24, then 36. We can just keep on adding 12s that way. All right, and answer this question, you know, how many can we buy for $12 each? Well, clearly we can buy one. We can also buy two because that's only 24. I did three, that's 36. But a little easier way is to, set up your equation here to see if you can buy 6. So for this one here, we want to know that the number of Blu-rays, that's what we're looking for. So we'll make that our X value. So it's 12 times X. So 12 times X gets us our number of Blu-rays that we're hopefully getting. And then we can only spend $60. So this is what I was talking about before. You're spending $60. So we could actually make this an equal sign right now to figure out how many we could actually buy. Hopefully it comes out to a whole number. If it didn't, it came out to a decimal number, then we'd have to do some rounding and more explaining from there. But considering it's inequality, and it says no more than, and we're going to see this in a moment in our notes, no more than is a less than or equal to $60. And then we would just divide by 12. And we get an X has to be less than or equal to 5. So we can only buy 5 DVDs. So our X is less than or equal to 5. That's all we can buy. So we can choose, if we have $60 to spend, we can buy up to 5 DVDs, 4 DVDs, 3 DVDs, 2, 1, or even 0 if we don't want any. So second question, can you buy 6 DVDs / Blu-rays? And the answer is no, because it has to be less than or equal to 5. All right. Another setup problem here from a story problem, and then we'll get to the bottom here and break out all of our symbols and what they mean here. So we'll put it all together. So it says the lowest elevation recorded in the United States is a minus 282 feet at Death Valley, California. Use this fact to write and graph an inequality that describes the elevation of the United States. So this is the lowest part in the United States. So I might start there and say, okay, that's my lowest part in the United States. So everything has to be the same as that or greater. So considering I already have written this down, I know that's my lowest number, so everything else has to be greater than that. So here we have everything else being greater. Now, this is sort of backwards way to write it. We always want to write our inequalities, especially when we're graphing them. You want to write the X is first. So X is greater than or equal to a minus 282. So again, this X has to be greater than that because that is the lowest number possible there in Death Valley. We don't have anything else lower than that. So your number line, you kind of tend to write it this way, but you do want to switch around so it graphs out a lot nicer this way. When you're graphing inequalities, always state where 0 is. So you do a little hash with 0. Then you can do like hundreds if you want. So you pick some arbitrary number. So 100, 200, And I'm just going to write down 282 because that's the actual one that we need. And then go the opposite direction also. So minus 100, minus 200, and then a minus 282. So I like to write at least both the positive and negative of whatever answer that we're looking at there. And this is just one single number. We'll look at ones that have multiple numbers later. So I'll talk about that later too. So here we have this one. If it is a greater than or equal to, it has this equal to sign on the bottom. That means it's a filled in dot. At 282, that is the negative. And we want everything that's greater than that. So our arrow actually points to the right. And one way of making sure this is correct is putting that variable first, because then our arrows kind of help us here. So in the direction that we need to go. So this greater than or equal to symbol, the actual arrow points the same direction on your graph as long as you have the variable first there. So we do have some signs here, some symbols. So we have the less than symbol. So all of these you always read left to right. And again, please put the variable in front. So this is just the symbols that we're referencing. So this one here, let me scroll up so we can see it, is also associated with less than. You might even see the term fewer than. And basically it means smaller than. So there's our less than symbol. Our greater than is the opposite way. And again, we always read these left to right, so you'd have some information over here. So usually it'd be the variable, x is greater than some number. So greater than. Another one is more than. These are very important words to reference, especially when you are going into your story problems like we had up here. And I'll reference them here in just a second. And basically the meaning of this is it is bigger than. We talked about our less than or equal to sign. So less than or equal to. Another way to say is at most. So is at most will be the same symbol. And actually we have a third one, is no more than. Is no more than. So we got three of those there. So this is smaller than or equal to. Is a nice little smaller than or equal to. For our less than or equal to symbol. And then last but definitely not least is there greater than or equal to. So that's the first one here. Greater than, greater than or equal to. You will also see it as is at least. So is at least. And the third one here is no less than. So again, all three of these are very common in our story problems. So greater than or equal to, that's like the easiest one because that's the name of this symbol, is at least. So again, you gotta kind of watch these two here. Is at most, is at least, and then the is no more than or is no less than. So it's kind of backwards here because this is a greater than symbol. These words kind of are a little bit backwards here, these second two. And again, this is bigger than or equal to for the meaning. Bigger than or equal to. So when we were writing our questions, notice we saw some of these up here already. So it said here, if you have no more than $60. So where did we see no more than? Right here, no more than, oops, I'll get that on there, no more than, and notice what sign we used, the less than or equal to, which we used up here in this question also. Here, says here, the lowest elevation recorded, death value was a minus 282, writing an inequality to describe that. So that is the lowest. So in this one, we kind of had to go with our knowledge a little bit of the sentence here that says it is the lowest elevation, so it can equal, all right? So that got us into the equals there. And then again, we used our less than or equal to sign. So we're going to use this chart here a little bit on the back side as well. So I'll flip over my sheet. And again, just practicing here, write an equality from each sentence there. So make sure that we are watching those. So let's go through those here. So a number W minus 3.5 is no more than minus 2. So again, if you need some help right now, go back over it. What is that no more than? Remember, that's the tricky one. I think it's more than, so you should be like a greater than symbol, but the no more than is our less than or equal to symbol. All right, so I know I'm going to have a less than or equal to symbol in this. So there's my less than or equal to, no more than, and that minus 2 goes on the right side. First part, W minus 3.5. So on the left side, it's going to be W minus 3.5 is no more than, so that is our less than or equal to sign, minus 2. And if we wanted to solve for there, we can solve for there. Quotient. All right, that is a divide sign there, ladies and gentlemen. So the division of a number n and 2. So I have n divided by 2 is at most. So again, this is one of those tricky ones again. Is at most is our greater than or equal to sign, 16. So is at most greater than or equal to our 16. And before I go any further, again, I just was looking at this again and I did it too. Is at most. So again, is at most. We think it should be greater than. Is at most is a less than sign. So I did it again also here, ladies and gentlemen. So please watch that. So less than or equal to sign. So let me flip my page back over here. Is at most. Less than or equal to. So again, like I said, these can be kind of confusing here. You really got to get your mind set at the is at most, is no more than. Is at least, is no less than. So those, again, kind of go backwards or you're going to get in trouble like I almost did. Again, it's always good to review to make sure that it is making sense. So n over 2 is less than or equal to 16 there. So watch that one. Next one, we have a number Q is at least 5. All right. So Q is at least 5. So at least 5. We're going to get this one correct this time. So I'm going to actually write out the Q first. At least is our opposite one, greater than or equals to. 5, comma, and Q, write my Q down again, less than, so that's just the straight less than symbol, 17. Now, when you have 2, ladies and gentlemen, mention this on the front side there, when we have 2, we can leave them separated like this, but we also clean it up here to one inequality structure. So you'll have the smallest number first. So 5 is my smallest number. Q is going to be put in the middle. So for Q to be put in the middle, I actually have to switch this all around. So make sure your arrows here in the greater than or less than sign stay exactly the same way pointing. So notice they point towards that 5. They were pointing towards the 5 to begin with. Put my Q in the middle. And then we're going to wrap it up here with Q is already in the middle. And 17 is my larger number. So here it says Q is greater than or equal to 5, but Q is also less than 17. So again, just watch those, especially the at least, the at most, the no more thans. You saw me mess that one up. I caught myself. So make sure we're watching that. Write an inequality that's represented by the graph. So we had one graph already that we did. Solid dots are an equal to. So it's either going to be greater than or less than. So it's an equal to. And then we get the greater than or less than part from which way our arrows are pointing here. So if we're going to write the inequality, we're going to use the same variable for all of these. We'll use x. You could use any variable. We're going to put that variable down first. So x. And then we know here we're looking at smaller numbers. So x is going to be less than, and again, the dot filled in is our equal sign, less than or equal to 4, because that's where the dot is. And then you can test yourself with that by asking yourself, okay, does this make sense? Is 1 less than or equal to 4? Yes. Is 0 less than or equal to 4? Yes. If we thought 8, no, 8 is not. 8 is a greater than. Here's an example of an open dot. So this will be just a less than or a greater than. All depends on which way our arrow is going. So again, put the variable down first. And we know it's going to be, and this is a little cheat, you heard me say it before, x is going to be greater than a minus 2. So the dot where it is, whether it's open or closed, that's always the number that we're putting down after our greater than or less than symbol. We graphed this a moment ago, and hopefully you're catching on to this. The actual symbol, ladies and gentlemen, goes the same direction. As long as you have that variable first, the arrow goes to the same way the symbol goes. You just have to watch out for the equal sign or no equal sign. Here, same thing. Arrow went off to the right. So there we go. As long as we're putting the variable first. So again, if I didn't know my terminology, I would at least know this is here, starting the variable first. My arrow points off to the right. So the arrow head points to the right. It's filled in. That's an equal sign. And then my minus 7, which does read x is greater than or equal to minus 7. And then the last one here, x. Again, my arrowhead points this direction. It's less than, and it's open, so there's no equal sign, and 0. Last one here for our notes, story problem. So you are shopping for a bicycle. The type you want cost at least $185. So that at least has popped up before, so we really want to pay attention to that. You have saved $97. Find the possible amount of money you need to save to buy the bicycle you want. All right, so we're shopping for a bike. So that bike right there, we're going to make x. So x does equal our bike. We're going to start out just simple at first. So let's take care of this first one, and then we'll modify as we go on. So it says the type you want, so the bike that you want costs at least 185. So the bike I want cost at least, so then remember that at least is the greater than or equal to sign, $185. So it cost at least that much. Moving forward here, we're going to modify it. So you have saved $97. So here, we're going to modify the left side of it because this is what we have saved. So we're going to go x plus 97 is greater than or equal to 185. So again, we're spending at least $185. So we have to be spending $185 or more. That's what we're doing. That's how we set that up. Just to clarify it there again. We have saved 97. So that is going to come off from our inequality here. So we're going to get back to x. So this is the original equation from what we read. We just started out with the first one and modified it with what we've saved. So we're adding that 97 to that price, which in turn actually takes away from here because we're solving it. So x, once we minus 97 from both sides, is going to be greater than or equal to, and 97 minus 185 is going to be, I do believe, 88. $88. So find the possible amounts of money you need to save. So this is our inequality here for the amount of money that we still need to save to buy the bicycle that we want. So right now we know we have to have at least $88 or more, because again, bicycles go up in price. 185 is the cheapest, and it'll just increase from there. So it could be a $200 bicycle, $300 bicycle, so on and so forth. So once we have that, we get our number line. Again, always have 0, and then the two numbers, the positive and negative. So I'm just going to keep it nice and simple. Do both the positive and negative. We are at 88. So it is an equal sign on the bottom. So it is shaded in. And then like our little cheat, the arrow, as long as the variable is first, again, if that variable isn't first, it's going to go the opposite way. So always put the variable first so you don't get confused, and we know it's going to be this way. So we have to save, and you might want to, maybe put 100 down here as the next number. Will 100 be a solution? Yes, 100 is bigger than 88. So we can save more and more and more money. It just depends on what bike we choose. Thank you, ladies and gentlemen.